Hello and welcome. These are the solutions to quiz 35. So which ion below has the smallest ionic radius? And so for this question here, what I might do is compare some of these ions have the same count of electrons. These three ions in A, B, and C all have 18 electrons. K plus has 19 for K0 minus 1 for K plus. That's 18 electrons. Calcium has 18 electrons, as does chloride. Chloride, bromide, iodide, though, are in the same group. Bromide would have 36 electrons, iodide 54 electrons. The issue here is that chloride is definitely going to be smaller than bromide, definitely smaller than iodide, just from the top to bottom trend of increasing size. And so then what about potassium and calcium? Well, K plus is the next smallest, and calcium is the overall smallest ion here in the answer to the question, because these three, which are isoelectronic, all 18 electrons, we want to look at the proton counts. Only 17 positive particles to hold in 18 electrons in chloride, but we have 20 protons in the case of calcium, but only 19 protons in the case of potassium. So more protons can hold in the same count of electrons more tightly, creating a smaller ion as a result. So calcium's the answer to number one. Number two is getting at one little detail, that is well, maybe two details, that the second ionization energy is always higher than the first. The third would always be higher than the second. So this is just going to be a general trend that 2 is going to be greater than 1, 3 is greater than 2, etc. And then we're going to get a huge jump, though, whenever we start removing a core electron. So when I look from the 6th to the 7th removed electron, I get this tremendous jump in energy. This is going to be because this electron here corresponds to removing a core electron. And so the key here is that from this diagram, I can see that whatever the element is, it should contain 6 valence electrons, because losing each successive electron just resulted in a small increase in energy. Then the 7th electron removed, that's going to be a big jump corresponding to a much higher energy electron being removed. And so this would fit the pattern for sulfur. So I'm just looking for an element that has 6 valence electrons, so that the 7th electron removed is one of the core electrons. So we have 5 for phosphorus, so we'd see this big jump between the 5th and the 6th if this were phosphorus. If this was argon, argon has 8 valence electrons, we'd see the big jump between the 8th and the 9th electron. So we're just looking at the big jump of energies coming between 6 and 7. So the 7th electron is the removal of the first core electron for this particular element. So which of the following atoms has the greatest first ionization energy? So ionization energy generally increasing from left to right. So the ionization energy as we go left to right increases, and then the ionization energy as we go from top to bottom is usually a decrease. Okay, and so it looks like I have elements cesium, sodium, chloride, iodide, and then argon. So the issue here is that I get this increase here. Now, of course, it goes increase, then a slight decrease, then a decrease, then an increase. And so chloride, argon should definitely be higher in ionization energy than sodium. Sodium should be higher than cesium because we get that drop from top to bottom. And then likewise a drop as well to iodide. So chloride and argon are going to be of the highest, and then argon is further to the left, so further to the right, so argon should be the highest of these elements in terms of the first ionization energy. So ionization energy generally increasing from left to right, a little bit of periodic inconsistency. The periodic inconsistency has nothing to do with this problem. Sodium should have a lower IE than chlorine. Chlorine is lower than argon. Of these three elements in this group, argon definitely has the highest. But then we realize that sodium is higher than cesium. Iodine's, that cesium and iodine are going to be lower than the third row elements, so that they are not going to be possible for the greatest ionization energy. Okay, number 4, which element most likely has the most positive electron affinities? And these questions are just usually getting at the noble gases, or the group that have the most positive as an entire category. In fact, there's no other category that's all positive. There's a few elements in the beryllium group that are positive, and the same thing with the nitrogen group that are positive, but not necessarily the entire group if you were to inspect. So it's really just the noble gas group that we'd expect to be the most positive in terms of their electron affinities. Which of the following atoms or ions have the largest radius? So another radius question, but now we're looking for the biggest one. And so one of the keys is that these particular ions here, we need to pull up a periodic table, but I think they have 54 electrons. Just pulling up a periodic table. Open, come on. So tellurium, 54 electrons. Cerium, element number 58, loses 4 electrons, 54 electrons as well. Iodide, 54 electrons. Barium, 56 minus 2, 54 electrons. Bromide, only 36 electrons. Looking for the biggest. So bromide is definitely going to be smaller than iodide, so bromide can't be the answer to the question. And then when we're ranking the isoelectronic ions relative to each other, it will be the ion with the fewest number of protons, so that's going to be tellurium because that's only 52 protons, 53 in the case of iodide, 58 in the case of cerium, and barium only 56 protons. So the smallest would be the Ce4+, the biggest is going to be the telluride ion. So Te2-. Electron configuration of ion 3+. Consider iron 0. Iron 0 would be an argon 4s2. Use a periodic table to make sure you get this right. And then you're going to lose the larger electrons first. That's going to be the s block. The d block are within the n equals 3 space, so they're smaller. So we're going to lose the s2 first, and then one of the d electrons to go down to an argon 3d5. So it should be argon 3d5. Sometimes these questions just get at the unpaired electrons, so that if you do this correctly, you come up with 5 unpaired electrons for iron 3+, as opposed to maybe removing all 3 from the d subshell and maybe guessing incorrectly that it has 3. So sometimes these questions just get at electron pair, unpaired electron counts as a way of asking for the configuration indirectly. Moving ahead to number 7, ionization energy versus electron affinity. So let's see here, write out the ionization energy of chloride. So ionization energy of this ion. Ionization is the loss of an electron. Lose 1 electron. That's this reaction here. And then the first electron affinity of the chlorine atom would be chlorine absorbing an electron going to Cl-. So this corresponds to the electron affinity of Cl. This corresponds to the ionization energy of this chloride. And you can see that these are the opposite each other. If you flip the one reaction, you get the other. So the IE1 of Cl- is equal to the negative of the electron affinity of Cl. Okay, the electron affinity of chloride would be adding an electron to Cl. So the electron affinity of Cl- would be this, adding another electron going to Cl2-. There's no connection that unites those two energies. So this is just nonsense for the suggestion of chloride ion for the electron affinity of chloride. So it's the IE1 of Cl-. The first ionization energy of chloride ion is equal to the negative of the electron affinity of Cl. Which of the compounds below has the greatest lattice energy? This is a question from chapter 8. This sort of snuck on here. Though we were talking about lattice energy. Lattice energy is the energy it takes to separate these compounds into their gaseous ions. It's a way of measuring the ionic bond strength. That lattice energy is going to increase with the magnitudes of charge. And then if the magnitudes of charge are the same, it's going to increase with the decreasing size of the ions. So ions that are closer together are more attracted. Okay, so we're going to look for the highest charged ions for the greatest lattice energy. That's going to be these two. These are the 2 plus 2 minuses, less than a 2 plus minus, less than a plus minus for the NABR. So NABR is going to have the lowest lattice energy, so that's not going to have the highest. CaBr2 and MgF2 are going to be in the middle, so they're not going to be the highest. CaO, the 2 plus 2 minus, are going to be the greatest in terms of the lattice energy, and CaO is simply smaller than BAS. The ions are smaller, they get closer together, harder to separate. So the answer to this one would be CaO. Like I said, though, this is a Chapter 8 idea, so it's a little bit ahead of where we're at in the class that we have discussed that particular effect a little bit. The valence electrons of which atom experience the greatest effective charge? So effective nuclear charge increases from left to right. This is why we get the decrease in size. And then we actually get a slight decrease from top to bottom a slight increase from top to bottom in the effective charge as the core electrons, as they're larger, are not shielding as much nuclear charge. So if you imagine, I like to just picture like sodium to potassium, you go from a core of 10 electrons to a core of 18 electrons. The core is bigger in the case of potassium, not screening as well. So more of the charge makes it out through to the one valence electron of potassium in comparison to that of sodium. Okay, so effective charge is going to be highest in the for iodine. So if you're thinking from left to right, it's going to be highest in the case of the lower right side of the periodic table because it's increasing to the right side and increasing down. So iodine will be the highest of these elements. Size, greatest size. So sodium, 3s1 is going to be bigger than without having the 3s1. So cation is always smaller than their uncharged counterpart, so the uncharged counterpart here is bigger. Add an ion, the ion is bigger. So F- is bigger than F because we have one more electron. More repulsions makes the ion grow in size. NAF is the atomic size trend that from left to right we get a decrease in size, but then the size is still increasing from top to bottom. So when we're looking at this trend here, what we might do is reason out that sodium must be bigger than chlorine, and chlorine must be bigger than fluorine, so therefore fluorine must be smaller than sodium. So sodium therefore must be bigger than fluorine. So sodium is the answer to 3. And then now isoelectronic, both of these have 10 electrons. So the bigger one is the one with fewer electrons. That's going to be F-. So we're looking for Na, F-, Na, F-. All right, so that looks like D. Sodium versus cesium. So does sodium or cesium have the greater first ionization energy, and then what's the explanation here? Well, our general trend from top to bottom is that ionization energy decreases from top to bottom. So cesium is going to have the lower ionization energy than sodium. And it's because it's, cesium has a lower, we're looking for the higher. So cesium's is lower, so sodium is higher. Sodium has the higher ionization energy because its valence electrons are closer to its nucleus. Cesium's valence shell is larger, so that valence electron's further away from its nucleus. So even though the effective charge does increase, so the valence electrons in cesium do indeed experience a greater effective charge, the fact that that is true, though, doesn't make the ionization energy of cesium higher than that of sodium. So that's a true statement in C, but it's not true, though, that cesium, because cesium does not actually have the higher first ionization energy. So despite the fact that the effective charge increases, the size of the atom plays a much bigger role in determining the ionization energy trend. So sodium being smaller puts that electron closer to the nucleus. So you put the electron closer to the nucleus. There's a greater energy it takes to separate the nucleus and the electron. And then you put the nucleus and the electron further away. There's less attraction due to the increase in size. And so further away with a bigger atom has a lower ionization energy. So sodium higher because its valence electrons are closer to its nucleus than cesium's are. And finally for 12, which element below has the greatest, most positive electron, or first electron affinity? So the first electron affinity is the energy to add in the first electron. Most positive, the greatest, will be neon. The most negative for this group we'd expect would be fluorine. Most of these generally are negative, and with the exception sometimes of the NS2 group, because we're putting the electron in a higher energy subshell, and then the MP3s are sometimes not as negative, or not negative at all sometimes, because we're spin pairing electrons and that takes energy as well. Okay, that's all for this quiz. Thanks for the attention.